Hello all, hope you're doing well. I'm going to go over this problem of finding area between the function f as written on my screen and x-axis. So the function is given by x times x minus 1 and x minus 3. As you can see, it's a cubic function because you have three linear functions x minus 3 linear factors x minus 1 and x minus 3. So it's a cubic polynomial. If I have to multiply this, I get x cube minus 4x square and plus 3x, right? So if I multiply the first two, I get x squared minus x. And then if I multiply further, I get x cubed minus 4x squared plus 3x. So first of all, it's a cubic function, positive coefficient of x cube, which is 1. So all of the cubic functions, they have end behavior like this. So it starts from negative infinity and it goes to infinity. The other thing, it is a nice cubic function. It is already written in the factored form. It has three factors, x minus 1 and x minus 3. So it means it has three x-intercepts, as you can see in the graph. It crosses 0, it crosses 1 linearly, and it also crosses 3. So this is 3, this is 1, and that's 0. So it comes from negative infinity, it crosses 0, it turns around and then crosses 1. It again turns around and crosses 3. I'm not concerned about the local maximum and minimum right here. I don't need them here. I just need to figure out the area between the function f and x-axis from 0 to 3. So basically I'm looking for this area A1 and A2. So I'm going to calculate A1 plus A2, whatever that area is. Now note here that A1 is positive because it's above x-axis, but A2 is negative because it's below x-axis, right? Now to calculate A1, it is from 0 to, integral from 0 to 1 f of x dx. But to calculate A2, this is given by integral from 1 to 3. That's your integral from 1 to 3, and that's given by, it's the absolute value of the integral because it's negative f of x dx. So to calculate the overall area between the function and x-axis, I would be adding a1 and a2, or I would be adding the two integrals given on the right side. So let's calculate a1 first. So a1 is given by, let me zoom in a little bit. So a1 is given by, if I calculate a1, which is 0 to 1 f of x dx, and I'm going to use my cubic polynomial, which is x cubed minus 4x squared plus 3x. So to use the cubic polynomial, to write the cubic polynomial, I'm going to write here x cube minus 4x squared and plus 3x dx. Now to evaluate this, I will be calculating the antiderivatives right here. So to find the antiderivative right here, the antiderivative of x cube is x to the 4 by 4. The antiderivative of 4x squared, 4 is a constant, so x cubed by 3, and again plus 3 x squared by 2. So I'm using power rule, adding a power, adding 1 to the power and dividing by the same number. And this goes from 0 to 1. Right? So using fundamental theorem of calculus, this is given by, if I apply 1/4 minus 4/3 plus 3/2. And if I take the GCD of this, which will be 12, so this becomes a 3 minus a 16 plus 18, and that comes out to be 5/12. Right? Because 18 plus 3 is 21, 21 minus 16 is 5. So now let's go to the A2, which is from 1 to 3. So to calculate my A2, I have to do absolute value of 1 to 3, the same integral, the same function, x cubed minus 4x squared plus 3x dx, right? Absolute value of this, which is same antiderivative, x to the 4 by 4, 4x cubed by 3 plus 3x squared by 2 and now your integral is from 1 to 3, and then you have to take the absolute value. This will come out to be negative. That's why we are taking the absolute value of this. So that equals, if I apply 3, it's 3 to the 4 by 4 minus 4 times 3 cubed by 3 plus 3 times 3 squared by 2 minus, when I apply 1 to this, when I applied 1 to this, I got 512. So I'm going to write 5 over 12 here because we already got 512 in A1. Now note that here I didn't apply the lower limit 0, because if I apply 0 to any of these x's, you are going to get 0. So usually when you find the entire derivative, according to the fundamental theorem of calculus, you apply upper limit minus the lower limit. Now in A1, I did not apply 0 because my outcome will be 0 if I input 0. So this is what you have, and then you take the absolute value of this, which is equal to 81 by 4 minus one of the 3's cancel. I get 36 by just 36, not 36 by anything. So just the 36 plus 27 by 2 and minus 5/12. So let's calculate these first. So if I calculate this, I have my 4 as my common denominator, or we can calculate simultaneously. So I have my 4 as my common denominator, which is 81 minus 144 and plus 54, and there is your minus 5 over 12, and the absolute value is everywhere, right? So this is your 135 minus 144, so which is a negative 9 over 4 minus 5 over 12 absolute value. So which is 9/4 plus 5/12. So 12 is your denominator, greatest common denominator. And here becomes 9 times 3 is 27. So it's 27 plus 5, and that's your 32 by 12. Now this 32 by 12 is your A2, right? So A2 is your 32 by 12 right here. So A1 is 5 over 12 right here. Let's go back here, and we have A1. A1 is 5 over 12, and A2 is coming out to be 32 over 12. So overall, A1 plus A2, the area between the function and your x-axis, is given by 37 over 12. So Um, just one thing to note here is that whenever you are below x-axis, your outcome is negative. Your answer, the entire derivative is negative, not the entire derivative, the integral from whatever domain you are looking at, whatever intervals you are looking at, it's negative. And when you are above x-axis, it's positive. Now this question asked for the area or the total area between the function and x-axis from 0 to 3. If the question was what is the net area, the net area would have been 0 to 3 of f of x dx. Now in that case, it would have been 5/12, which is your 0 to 1, minus your 32 over 12. It's A1 minus A2, so which is negative 27 over 12. So net area could be negative, net area could be positive, net area could be 0. But total area is always positive. Total area, you have to take the absolutes of each and every area. Below x-axis, take the absolute. Above x-axis, it's already positive. Another way to differentiate net area and total area is you can think of, or the simile would be distance. Thinking about distance, in one direction it covered this much distance, and when it went in the opposite direction, it covered this much distance. But when we talk about net area, an analogy will be displacement. It could be 0, it could be negative, maybe it traveled more in the negative direction, in the opposite direction, or it could be displacement could be 0. I went from my house to Lone Star College and came back to my house, so my displacement is 0, whereas my distance could be the twice of the distance covered on the one side. So so when you're calculating net area, just simply do the integral. When you're calculating total area, you have to break the integrals depending on when the function is going down, when the function is going, it's above x-axis. Hope this helps, and thank you for listening to me, and take care.